This video is going to show you how to use this script to create a Raydium swap exchange script. It's super simple. It's around 113 lines, but if I take out the spaces and comments, I bet it's even shorter. So why am I working on this script? I've worked on similar scripts before, but those were using some APIs to get the corresponding trading pairs. Then these APIs return the corresponding TX, and we do a signature and send it to the blockchain. Recently, some of our students were asking me if they could use it. Some of our students asked me if I could make a demo using Raydium SDK because they don't want to use paid APIs like JUP or some others. Sometimes it crashes, right? So I made this script just for that. Alright, let's get to the point and break it down. How it's made. I can't provide the download for this script because of safety issues. If you want to use it, just set up an account, watch our videos, and gradually figure it out yourself. That's what I'm doing here. I'll show you all the code too. Just in case anyone says they downloaded my file and ended up with a virus or something, then I wouldn't be able to explain it, right? I hope everyone uses these scripts only after fully understanding the code involved. Hey, crypto isn't just for programmers. I'm Gida, and on this channel, I'm here to take you from beginner to Web3 Pro. If this sounds like your kind of thing, make sure you subscribe and smash that like button to stay competitive in the Web3 space. Leveling up your skills as a DApp developer is the way to go. Head over to our homepage, and I'll guide you through every step of the journey. Okay, and the first 8 lines are just some dependencies. So, here we're using stuff like Solana Web3.js, and there's Anchor. Plus there's the Raydium Beta version. They also have a V1 version, but I didn't run the V1 version either. I went straight to run V2. And then there's a BN, which is a number conversion tool, and a dependency to get files, the S58. Which is specifically a tool for compiling what's needed. Alright, there are also 2 tools, and those 2 tools are to initialize the SDK. Also, there's a tool to determine if a pool is of the CLM type. We know that in Raydium, there are 2 types of pools. One is AMM, and the other is CLMM. They're different types. You know, the way it's used is different, and the rest is about creating it. Alright, next up we see line 11, which is about creating this connection. If you're using the RPC for the mainnet, you might run into a common issue where it gets stuck. This usually happens if you're making requests frequently, and then the official RPC might feel like you're overusing it, and then it will limit you. So, usually, we create some dedicated RPCs for ourselves. We can set those up on Alchemy. Our dedicated Solana node has its limits. Of course, if you go over the limit, it'll restrict you. If you want to avoid limits altogether, you can pay for it yourself. And then we have the wallet, which is our wallet object. As for the private key, I've hidden it here, so you can put the private key in here, or like I did, use this env to hide it, and just write it in your config file. Then we need to define a variable. It's called pool ID, which is basically the ID for the pool we want to swap in, kind of like what we have in Ethereum. Find the address of the LP token. We can check it out on Deck's screen to see its LP or something related to it. What's the POO ID? I'll just pick one randomly. And what's that in the bottom right? There's a pair, which is this 2AXX. This is the pool ID for this trading pair. So, we're not actually looking to fill in the addresses for the 2 tokens here. He just needs to fill in a pool ID here. Find the pool ID easily. You can either use some APIs, or Raydium also has their own options. You can also look it up using some APIs, but if that's not the way you want to do it, just find a file and get it yourself. You can store it in one place. And there's also this input mint, which is basically the address of a token I'm inputting. I'll need that parameter later. Then there's also input AMT. We can't just input the numbers directly, we have to wrap a BN around them. We can't use them recklessly, they definitely need to be used with this kind of buff. The type has to be able to read it. So, moving on from line 23 to line 104. That whole function is, our swap exchange is just like trading. So why don't we have buying and selling anymore? Basically, when we use the swap to exchange, it's basically the same as buying or selling, or just a token. Can we switch to B token? If you're selling, you can just reverse its swap B token back to A token, and that should do the trick. Alright, cool. I've added some comments here for you. Lines 28 to 32 are about getting some information from the pool. You know, we have that PID, the pool ID. So, we can use the Raydium SDK, specifically to get pool info from our PC function in the CLMM. To get all kinds of information about the pool. It includes its stick data, trading info, and all sorts of keys and accounts. It's all here. So what's next? We need to check line 34 to see if it's CLMM. So what if it is? And if it's not? Just pop up an error. But if you want to be more precise, you can also make a distinction. If you're CLMM, we'll go with this function. If not, we can choose the other function, and that's fine too. It's pretty versatile. So this is just a demo, so I didn't go into too much detail. And then over here, we need the tokens. One example of a public key is when you've worked on some Solana projects. You might notice that you can't just input the address directly. You need to use this public key to wrap an address. That's the only way it works, because that's what makes it an instance. And then you can pull up certain information from it. So here, it's about creating instances for these two tokens. And then you can use the base 58 to get their token addresses. You know what I mean. Alright, it's 43 lines. And it basically checks if this token matches what's in the pool. It's checking whether there's one here. And it's looking for the token address that we input. So, if it's not equal to and token is not equal to btoken, then if neither of them are equal, it basically means our input, this address, it's not coming from this pool, just checking this one. So, on line 47, we need to compare the address of our input token. Does that mean it's equal to the address of Minta? If that's the case, then basin is true, which is correct. But, if it's not, then, so if the input address isn't equal to address A, then it must be equal to address B, which means he should choose false, indicating it's wrong. Why is that? It's because we don't know which tokens a token and B token actually are. But we do know the address of our input. It's either this or that. So, he needs to figure out if he's buying or selling. That's the point. That probably means buying. But if it's not that, then it means selling. However, in a swap, there's no buying or selling. So it's just in and out. So if we jump to line 68, there's this component data, right? This token out is used to tell if it's a buy or sell. So, it's about whether to exchange from A to B, or from B to A. That's the idea. Alright, let's flip it around and account for lines 50-51. We've got user token account A and user token account B. And this is where we figure out our token account, like what address it is, if we haven't done this before. When it comes to developing on Solana, it can be pretty confusing to understand what a token account is, especially if you're coming from either ARM or other EVM-compatible chains. There's no such concept. Just to give you an example, if I have a user address like xxxxxx, and if that xxxxxxxxxxx needs to store a token, then it doesn't just put this token directly into that address. Instead, it has to be stored in the token account under that address. And that token account only holds one type of token. If you need to store token B, then you'll need to have token B. The token account is this thing right here. It's a personal user address and you can create countless of these below. This storage is for different token accounts. So what exactly is the address of this token account? We can find out by using get token accounts by owner under this connection. This function calculates everything for us. We just need to pass in parameters like the wallet address and the token address, and it'll create a token account. So, if it calculates something and the number created is not equal to 0, it definitely needs to be created. But what happens if it hasn't been created? He's just creating one here. And the reason is that if you don't have that token in your wallet, then the token account hasn't been created. He has to create it first to use it. Because in Solana's system, all the data exists in different accounts. There's a rental period. And you definitely need to pay a little fee for them to help store your information. So, if you haven't created that kind of account before, you'll need to set one up. Otherwise, he won't be able to use it. Even if you figure it out, you don't have that account. You know what I mean. So moving on. It's about line 64 to 71. Calculating the minimum output amount, which is the number of tokens I input. So, what's the amount I can get out? Or how much I can exchange? I definitely need to give you a threshold. Right? Because if I don't give you a limit, you'll just throw out any random number. For a structured learning path and developing Web3 projects on Solana and other EVM chains, make sure to follow our channel for more tech insights. If you'd like to join our bootcamp, head over to my Patreon. With a free subscription, you'll receive a Web3 project development learning blueprint, outlining the essential skills to quickly build your own dApp. See you there.